All right, can everyone kind of sort of see that? Okay. All right, so let's go ahead, and I'm not going to put the numbers in on this thing, but I'm going to kind of set this up for you. And I'll tell you that you will have a planetary gear set problem on the final exam. All right. So if you don't follow this, then you probably won't be able to do the homework, not the homework problem, but the problem on the final exam. Okay. All right. So remember what we said is we have these steps that I gave to you on November 29th, last Wednesday. So in that, I said to first label all pitch points where gears are meshing, guess all your directions for your gears and arms, the omegas, to be positive. Draw the linear velocity vectors on each side of the pitch points in centers of gears carried by the arm based on the omega directions. And then lastly, write one equation at each pitch point. All right, so I'll kind of show you how this is done for the two homework problems. So on this here, let's go ahead and label all the pitch points first. So I have a pitch point here. That's P. Then I have a pitch point here. Call that Q. And then a pitch point here. Call that R. Then what I'm going to do is guess all the omega directions being positive.
Why is Q there and not at the other side of the circle?
P, Q. Because, all right, so let's write that out. So P is at the join of 2 and 4. And Q is at the join of 3 and 5. And R is at the join of 5 and 6. Okay? So let's look at that. So where 2 and 4 are meeting, that's where P is. Where 3 and 5 are meeting, that's where Q is. And where 5 and this is called 6, I guess, are meeting, that's where R is. That answer your question?
Yes.
You see how 5 is overlapping 4? Would we know that if we hadn't seen that picture? Like the analysis we did?
If you just looked at this,
Like if we did analysis first and then we were going to draw it, we wouldn't know that though, right?
you did an analysis first. What do you mean by doing the analysis
Like
first?
you know how we analyze something and then we end up drawing the side view, the front view. There's no way to know when those two overlap.
Well, on this right here, I can look at this thing here. This would be all you get, all right? Well, you may actually have a side view or top view like this.
Okay, I didn't even see that you were at 3 and 4 were on top of each other. Okay, that makes sense. Sorry. Thank you.
Yeah. All right, so then, step 2 is to label the directions of these all being positive. So this is omega 2. This right here is omega 3, 4, because 3 and 4 are actually attached and moving together. All right? And then omega 5 is here. And then we have omega 6 is here. All right. Okay, so this right here, and then we have the arm, of course. So the arm, where do I want to write this? So the arm, we have omega arm going like that. Okay? All right. So now let's go ahead and label the pitch points. I mean, not label them, but see what's going on at each of these pitch points. So at this pitch point here, I have just on this side of this pitch point, I have this velocity vector here. And let me write it in terms of my gear tooth count. So that is omega 2 and 2. Then if I step over on the other side here, I have on this side, I have omega 3/4 times n4. So let me stop right there and entertain any questions. Yes?
Does it matter when we draw these if it's at an exact right angle?
No, but you want to, I mean, that right there, you want to kind of draw it like that so that.
But it doesn't matter exactly.
Right? Yes.
So omega 3/4 positive, maybe opposite.
Okay, so because of how we guessed our omega directions. So if I'm just focused on what's going on this side of the pitch point, and I see that omega 2 is going like that, that means the linear velocity vector shoots off that way. And because I guessed omega 3/4 being positive this way, if I step over the pitch point and just focus on this, the linear velocity vector is drawn down like that. Does that answer the question?
What about the linear velocity vector
For what?
for Q?
I'm going to do those. All right. So I'm going to do each of the pitch points. All right. There's,
Is the reason it's omega 3/4 and 4 and not n3 just because n4 is on the outside?
correct. R4, the radius from this center to here is R4.
Oh,
We
right.
make the substitution of the R4 with an N4
Why can you do that again?
because
They're proportional?
they're proportional.
Okay.
Okay, they have to be proportional. All right, what else? Okay, so the one thing that we have to also look at here is this right here. We need to find out how fast this center is moving. All right? So that right there is omega arm, the radius of 2, which I'm going to use N2, plus the radius of 4, which I'm going to use N4. That would be the linear velocity vector for the center of 3 and 4. Okay? Good on that? All right, so then we now encounter Q. With Q, we have, just on this side of the pitch point, we have omega 3/4 times n what? N3, N4, N5, what is it?
N3.
N3. Why is it N3? That's correct. Why is it N3?
We get the radius for N3.
Right. So the radius here is R3. And so we make that substitution R3, put N3 there. All right? So then we step over the pitch point and we find this one here. This one right here would be omega 3/4. Oh, I'm sorry,
Omega 5.
omega 5. Omega 5 times N5.
Why is that not omega 3, 4, and 4?
Because now we're on this side of the pitch point.
But it's still on the 4,
No, we're on the 5 now.
but don't they overlap?
They touch.
The 4 and 5?
4 and 5. No. 3 and 5 touch.
Oh, because that's on the point of 3 or 5. Oh.
Q is the pitch point between 3 and 5. So we have omega 5 times N5 because we guessed omega 5 going like that. So now let's go up to the center of the arm here. So then on the center of this arm, there's omega arm times N2
Plus N4.
plus N4 N3 plus what? N5. In other words, what we're doing is this distance here is R2, make the substitution N2. This distance here is R4, make the substitution N4. This distance here is R3, substitute N3. This distance here is R5, substitute N5. Okay? So then we keep on going and we get to this side of the pitch point of R. And I have this right here. That would be
Omega 5.
omega 5 times N5. I step over the pitch point and I have omega 6. So on this one here, I have omega 6 and N6. Okay? So I also want you to note here that R2 plus R3, no, R4, plus R3 plus 2 times R5, right? Has to equal R6. In order for everything to go together, it has to equal R6. So on that, I can say that N2 plus N4 plus N3 plus 2 times N5 equals N6. Okay? So those tooth counts need to add up to each other too. All right? Okay. So we're done with the linear velocity vector directions. And remember what we did is we decided by looking at these things what we're going to call positive and what we're going to call negative. So what side do you want to call? Do you want to call this positive or negative on this side?
Positive.
Positive. The reason why is I got 1, 2, 3, 4, 5, 6 directions going like that, and I only have 1, 2 going the other way. So this is going to be positive, this one's going to be negative.
Why did you make omega 6 and N6 go straight?